Okay, good day everyone. So today we will be discussing about hydraulics, pneumatics. Okay, so we will focus first on pneumatics. Okay, so at the end of this class, the participant should be able to explain the basic principle of pneumatics, recall the structure of a pneumatic system, identify the functions and use of pneumatic components, recognizing and drawing of symbols and circuit diagrams, and demonstrate practical construction of various pneumatic controls. And lastly, have a hands-on simulation of basic pneumatic system. Okay, so what is pneumatics? So it is a branch of science which deals with the study of gases, especially air. So its properties and application at pressure higher or lower than atmospheric pressure. So if it's higher, so it is a compressed air, and if it's lower than atmospheric pressure, then it is vacuum. Okay, so pneumatic comes from the word pneuma, derived from the Greek word meaning breath or wind. So it is the industrial implementation and application of air-powered actuators like cylinders and motors and their control devices like valves needed in their operation. Okay, so what are the usage of compressed air? So industrial applications employing pneumatics are for material handling like clamping, shifting, positioning, and orienting. So for general applications, packaging, milling, filling, metering, locking, door or chute control, transfer of materials, and for shipboard applications for engine starting system, control loop system for engine auxiliary machineries, gangway operations, fire dampers, emergency shut-off systems, and deck chipping equipment. So compressed air as a working medium have advantages like air is available everywhere. Compressed air is insensitive to temperature fluctuations. Compressed air can be stored and is explosion proof. It's clean, fast, and straight line movement can be produced directly. While the disadvantages are compressed air is a relatively expensive means of conveying energy. So it requires good conditioning. So it is only economical up to a certain force expenditure. So may limitation siya. Air is compressible. Uniform piston speed is impossible. So since it is compressible, there will be chances that it will have delays or it has limitations on its strength or power. Also, exhaust air is loud. Okay, so let's talk about structure of pneumatic systems. So pneumatic system uh, has first from the bottom we have to supply the energy. So by using compressor, pneumatic reservoir, pressure regulating valve, and service unit. And then after that, the energy will be um, transferred through a signal input like the directional valves, control valves, roller lever valves, proximity switches, air barriers. And then those input will be uh, used as a signal processing. So using and directional control valve, shuttle valves, dual pressure valves, pressure sequence valves, sequencers, and others. And then this signal processing will be uh, sent to a signal output using control elements, direction control valves, and then it will be used into command execution using cylinders, motors, optical indicators, and so much more. Okay, so sample of a pneumatic system. So here is a sample. So the energy is supplied here from the supply and then passed through a filter dryer and then through a valve. So we will discuss these symbols later. And then it will be transferred into input elements. These are the valves. And then a processing element. So this is a OR valve or a shuttle valve. And then to a control element, another directional valve, and through a working element, which is the piston cylinder. So this is just a sample. Okay, so let's go with the symbols. Okay, first, we have here a symbol for okay, so can I use a pen maybe? Okay, so this is a symbol for compressor. So it has no arrow, so it is a constant displacement volume. So it is not a variable speed compressor, so it's constant displacement. Next, we have pneumatic reservoir. So in this symbol, we store um, the air or the compressed air inside the tank. We have pressure source. We have filter. So there is a broken line and in between the diamond. And then we have a water separator. So this is water on the bottom, and then you drain it manually. So it has manual actuation of the drain. And this one is the filter with automatic drain. Okay, next we have a lubricator, and in here we have a pressure regulating valve with the relief port adjustable relief port. Okay, so why do we call that an adjustable relief port? Okay, so in this diagram, as you can see, if the pressure comes from the top side of the valve, so it will send pressure here on the broken line, pushing the valve to open so that pressure can move to the bottom. So that is for relieving pressure. But oops. But if the pressure comes from the bottom, so if the pressure comes from the bottom, it will go straight outside, and then that pressure, depending on the pressure, it will give signal here on the valve to close or to regulate the pressure. So the higher the pressure that comes out, the higher the regulating pressure to regulate the pressure inside the valve, so that the pressure that will go out will be regulated or will be controlled. Okay, so that's how it works. Okay, next we have a air service unit. We have a simplified representation of a service unit. So a service unit has a filter dryer, have a um, pressure regulating valve with the relief port, and then it also have a pressure gauge and a lubricator. That's a complete air service unit. But to simplify things, so they also use this symbol. So it is simplified representation of a service unit. So this is okay. So as you can see here, there is a line here, so it has a lubricator. But at the bottom, there is no line, so there is no without compressed air lubricator. Okay, okay. So you see the symbol. So this symbol is like this one. This is the lubricator. Okay, next. Direction control valve. So this is a picture of a control valve. So it is used to open and close flow paths, regulate pressure, direct flow to various paths, and adjust flow volume. Okay, so the symbol for this is this one. So this is a box. So this is a box. So inside the box is a valve. So one box meaning, or one square means that it has a one position. So in this one, there are two squares, so there are two positions. So number of switching positions, so two. Okay. On this square, there is one inlet and one outlet, so there are two ports. So the flow is open, so the flow enters from the bottom to the top. So there is flow. So the arrow indicates the direction of flow. Next, in this diagram, as we can see, there is no arrow. So the flow is the flow has been stopped. So the valve is closed or still closed. So there are two ports. Closed ports are shown by two lines drawn at right angles to one another. Okay, next in here we have two positions, so two squares, so two positions, and then we have one, two, three, four ports. So this is a four. There are four connecting lines. So you can put supply and exhaust air in this port or this connection. Okay. Okay, so let's check this one. So this is another valve. So it has a two ports, one and two, and then it has two positions. So this is what you call a two-way valve. Okay, so in this position, let's erase. So this is there is a flow, so the valve is open, and in this one there is no flow, so the valve is closed. So the switching positions may be identified by lowercase letters A, O, A, B, C. So these are the switching positions. So position A, and we have the position B. So there are two positions. And then there is an arrow here, so it depends if the position will change to that direction. Okay. So how about here at the bottom? So this is a valve with three switching positions. So there are three squares, so three switching positions, three positions. And the mid position is identified by the lowercase o or the neutral position. Okay. Next, designations of connections. So usually we have A, B, C, and 2, 4, 6 for working lines. We have power connections P and 1. We have exhaust, usually RST and 357, usually odd numbers. As you can see, 357. And we have control lines Y, X, Z, and 12, 14, 16. Okay, so those are the usual letters and numbers used in our designations for connections. Okay, so let's check here. So this valve, as we can see, there is two ports, one, or we can use the right side in this box. Okay, so there is one inlet and one outlet. So there are two ports. So that's what we put here, two ports. And then since it has two boxes or two squares, so we can say that it has two switching positions. So this is over two. So that's what we call as a two-way valve. And since uh, the square on the right side is there is flow, so this valve is open. So normally it has normally open position. So as you can see. Okay, how about here? We have one, two, and three ports. So we can put here three, and then it has two squares, so it has two positions. So this is two. So three two-way valve. And then as you can see on the right box or right square, it's let's erase first. As you can see from here, from one there is no flow to two. So the source has no flow. So since one is our source, there is no flow to two, so it is a closed position. So as you can see, this is a three two-way valve, normally closed position. Okay, next we have a three, another three, one, two, and three. So this is a three two-way valve, three ports and two positions, two squares. So three two-way valve, and then as you can see, there is flow from one to two. So that is normally open. So this is a normally open position. And then if we activate that, we move the box from left to right, so the new position will be closed. But if there is no actuation here, there is no movement, so this is a closed, normally open position. Okay, next here we have four ports, one, two, three, and four. We have four ports and then two position. And so this is what we call the four two-way valve. Next we have five ports, one, two, three, four, five. So five and two positions, so five two-way valve. Next we have the five three-way valve, which has five ports and then three positions. Okay, and the mid position or the neutral position is closed. As you can see, there is no flow, there is no arrow. Okay. Okay, let's go with the actuation. So this is our valve. We have a five two-way valve, this one. And then if you, this is the normal position, the square on the right side. And then if we want to activate the position here, we want to use this position, we need someone or something that will actuate this valve from the right square to the left square. So if we want to use this flow, we will have to use an actuator or an actuation method. So there are many kinds of actuation methods that we can use. First, we have general. So you can use it manual. We have push button. So if you push it, uh, the actuation will flow, or the valve will be activated. Okay, next we have a lever. Lever type is still manual. We hold the lever and then push it to wherever we want it to go. And then we have pedal. You can use your feet to activate this. We have detent. So detent is if you activate it, then the detent will, or the last position that you use will hold. So detent is something that will hold the valve in its last position. Okay, so it is like a holding contact. So it holds the valve to its last position. If you use the push button, for example, if you unpush the button, if you don't push it anymore, then um, it will go back, especially if there is a spring. So the spring, if you put spring in here, for example, so if you push the push button on this side, and then if you remove your hand, so the spring will push it back. But if it is detent, even if there is spring in there, so the detent will hold the uh, position of the valve in its last position. Okay, next we have button. We also have roller, idle roller, and we have, so these are all mechanical. We have also electrical, so we have solenoid. So if you put electricity, so the coil will um, compress, or will compress, and then will activate the valve or the solenoid. Next we have also pneumatic, so it is pressurized. So pneumatic pressure is used to activate for actuation method. Okay, so let's see. So this one, this is a 3-way valve. Since it has 1, 2, 3, 3 ports. So we have 1, 2, 3 ports, and then the port here is from the source, which is P or 1. So there is no flow. So this is a normally closed position 3-way valve, and then it has a pneumatic actuation with a spring return. Okay, next here we have a 3-way valve, normally closed still, but it is actuated from left, so we can actuate it using pneumatic, and on the right side we can also use pneumatic if you want to move it back to its original position. Okay, okay, next here we have, so this we have a 5 2-way valve. So there are 5 ports with 2 positions, and then normally open. And then we have here a, I think this is general, so it is manual activation, and we have also another activation here which is solenoid. And then in this one, I think, I'm not sure, since it has PZ here, so maybe it is piezoelectric, so I'm not sure with this one. So I think it's piezoelectric, so it is like a solenoid. It's electrically driven, or but sometimes, or but it also looks like a what's we call this, pneumatic pressure, since it is like an arrow, right? So it's like a pressure, so maybe it's piezoelectric. Okay, so I'm not sure with this one. Next we have here the 5 2-way valve with pneumatic actuation. Okay, so all pneumatic on both sides. Next, we'll go with this one. We have here a 2-way directional valve. So this is the what is inside the valve. Okay, So the original position is normally closed. So like this one, the spring is always pushing the ball so that the ball will close the valve. Okay. But if you put pressure in this button, so if you push this button, so the valve will move to the open position. So it will move to the open position. So this one will be activated, the open position, and then in the lower diagram, so as we can see, we push also this push button. If we push this push button, the ball will go down, and then there will be flow of the pneumatic air from P to A. Okay, so this is the mechanical part, or the mechanical diagram for this pneumatic diagram. Okay, next, so this is how it activates. If you push the button like in the diagram, so the flow will go from P to A, from P to A, and then maybe like it, if it moves a hydraulic motor, so the hydraulic motor will rotate. So if pressure goes, or this is a pneumatic motor, so the pneumatic motor will rotate based on this example. Okay, so this is a 3 two-way directional control valve, normally closed. So this is the normally closed 3 two-way valve. So source here is closed. So this is the source and it is closed, right? But if you push this button, so this one will go down, and then there will be flow from P to A. Okay, so this one, if you push this one, there will be flow from P to A. Okay, you get it? Okay, next we have the 3 two-way directional control valve single pilot operation. So as you can see here, this is a normally closed position from P to A, right? And then it has spring return and a pneumatic pressure to activate the valve. So in here, P is closed, so there is no flow. So this is a closed position. But if you put pressure in the Z, in this port, Z, so the valve or this sleeve will go down, and then the pressure from P will go to A, going to A. So in this diagram also, you can see as P will go to A, or at the top part. So these are the 3 two-way directional control valve. Okay. Next, we will go to non-return pneumatic valves. So it needs 2 pressure to activate the valve. And or shuttle valve, it means only 1 pressure or 1 flow is allowed. So let's see what these are. So first we have a check valve. So check valve, in this check valve, if you put pressure on this side, so the valve will close, right? But if you put pressure on the other side, there will be flow of pneumatic air. So this is a non-return valve or one-way valve, or also what we call a check valve, or sometimes it's called a shut-off uh, valve, or shut off the opposite direction. Okay, we have also a shuttle valve. So in this way, if pressure is in this side, so the pressure will push the ball to the left, and then pressure will flow from point Y to A. But if there is pressure on the other side, which is greater, so if there is pressure in the X, so the ball will be pushed to the right, and then there will be flow from X to A. So there is only one flow. Okay, so it's an or. So either, so that's also what we call a shuttle valve. Okay, next we have a 2 pressure valve. So if there is only higher pressure here, we have pressure in X. If we have pressure in X, So this spool will be pushed, and then it will close both inlet pressure. So there will be no flow in the valve. But if we yeah, and if we put pressure on the other side also, so this one will be closed and this one will be closed, so there will be no flow in the valve. But if both valves are do have pressure, so to have two pressure inlet ports, to obtain an output signal at A, compressed air must flow through both inlet ports. So like this one. So if you want to so if you want to have flow to this port A, there should have an equal pressure or a pressure in Y and a pressure in X, so that this spool will be leveled at the center, and then flow will occur from the sides to the center. But if there is only one pressure, then it will close the valve. There will be no flow. Okay, so this is a quick exhaust valve. So as you can see here, we have a pressure, and then if there is flow in here, the ball will go to the left side, and then the pressure will go up, and then this pressure will be the one who will be pushing back. Am I right? So let's see if there is pressure here. So one, or rather, okay, so if there is pressure from 1 to 2, right? Fast ventilation of stainless pipes. So if there is pressure, 1 goes to 2. And this red one will close the exhaust. But if there is no more pressure from the 1, so this valve will go down, and then pressure from 2 will relieve to 3. Okay, next we have flow control check valve. So if we turn this knob here, so we can adjust the level of this needle. So you can close down or open up, right? So let's see. Okay, so let's see the flow control here. So if there is flow in here, so there is restriction in here going to the next to the other side. So in here we have a restriction at the bottom, at the center, and then pressure will go here. So we can control this since this have an arrow, so it's variable, so we can adjust this one. So if you adjust this one, so we can control the flow, right? But if there is pressure on the other side, so if there's pressure on the other side, okay, let's see. If there is pressure, the pressure will go from left to right, so that is its flow. But if there is pressure on the unrestricted flow, for example here, there's pressure here, then it will push this check valve, or this one, to push so that the pressure will be relieved or go back to the other side. Okay, so this one is this one. So if we return the pressure, so it will go through this check valve or non-return and then go back. Okay, so that's how you control the flow. So next we have pneumatic actuators. So there are different kinds of actuators: single acting, double acting, rotary, vane, and pneumatic motors. So this is its diagram. If we put pressure in here, so that pressure will push the piston to the right. But if there is no pressure in here, so the spring will push back the piston to the left. or to its original position. So as you can see in the diagram also here, so these are single acting cylinders. So if there is pressure here, the piston will go to the right. But if there is no pressure here, so the spring will put it back to its original position. So there is only one uh, port to add pressure. So that is single acting. While we also have double, okay, this one. So if this is your valve, this is a push button with spring return, and then this is a 1, 2, 3, 3 two-way valve. Okay, so the flow here is closed in its normal position, but if you push the push button, so this um, this one will go to this one. Okay, so there will be opening of the flow or opening of the valve. So the flow will go here to here and then pushing the piston to the right. But you un if you will not push again, if you will not push this push button, so the spring will push back uh, will push the spring will push back this valve, and then there will be no flow, and then the spring also at the top will push the piston to its original position, and then the pressure here will be relieved or will move to the exhaust. Okay, so this is how it works. So the air will push the piston up, but if there is no more pressure, so the spring will push the piston down. So this is a single acting cylinder. Okay, we have a double acting cylinder like this one. So double acting. So if you put pressure in here, so the piston will go to the right. But if you put pressure on the right side, so the piston will go back to the left. Okay, so let's see how it works. So these are the parts. So let's see how it works. If you put pressure, so the piston will move to the right. And then if you put pressure on the other side, so the piston will move to the left. Okay, so that is a double acting cylinder with air cushioning. And then we also have rodless cylinder. So it doesn't have a rod. So if this cylinder will move to the left or to the right, so this one will move, but it doesn't have any rod in it. Like this one. So this is magnetically coupled. So this one will move to left to the right, but it doesn't have any rod. Okay, so let's see. So this is the conventional double acting cylinder, requires space to house the cylinder, while the more effective use of the available space can be made by using rodless cylinder. So the lesser space when we use a rodless cylinder. Okay, so this is a rotary cylinder, rack and pinion. So if the center, this driven shaft with gear. Okay, so if we put pressure on the piston, like this one, pressure on the piston will move from left to right at the top. So this one will move left to right, and then the rack will rotate this gear on the center, and then the gear in the center will also move the piston in the bottom to the left. So that's how it works. Okay, so it depends where the pressure will go. Okay, and then after this we will be having our pneumatic simulation exercises. Okay, so thank you for your time. I hope you learned something on this video presentation. Please subscribe and share our video, and I hope to see you on our next video. Thank you and bye.